Research Launch is open to you. Share your valuable thoughts with our students.
Thanks, Naini, and good afternoon to all of you. Thanks, Naini. Uh, so thank you very much. So today we are going to discuss about the topic we have chosen. Actually, me, Dr. Minghua Dingen, Chaturanga Veerathanam. So I got with Chaturanga through Zoom. Actually, we had a discussion and we made this presentation, short and sweet. The topic being from coursework to real research. Let's move on. The coursework requirement is quite important for a budding researcher. So we start from the coursework perspective, and then we'll discuss how the real research and coursework's requirement are intimately attached once we move. So this talk amounts to scratching the tip of this massive iceberg. If you look at carefully though, carefully enough, you can see a visible part is smaller than the invisible part. Underneath, you can see massive hull underneath, but on top, you can see very small part. So this talk and the content that we're going to discuss amounts to the same thing. The top part is visible. That means the non-research and non-knowledge and the coursework or whatever, the more well-documented research, documented knowledge is legal. Whereas the unknown thing, yet to be explored, quite a lot that massive. So I'm going to do a feeble exercise right now. Try to connect these two words and how to go from top to bottom as a guideline. So that's what I'm going to discuss. So let's move on. First, let's look at why do you want to do research? It's a very critical question, actually. Why do you want to do research? Why aren't you happy with whatever your basic knowledge? So if you move on to National Science Foundation of United States of America, it's taken except from that one. Look at carefully. It says that continuous economic process, intellectual process, requires continuous acquisition of new knowledge. Basically, this is what research means. Continuous acquisition of new knowledge, or basically creation of new knowledge. This is what NSF says. Now, another perspective comes from well celebrated, one of the most decorated physicists ever lived on this earth, Richard Feynman, very famous Feynman lectures. Actually, you must have heard at least one time in your life. He talked about research. Actually, according to him, actually, you have to doubt. Actually, you have to doubt the things, and you don't have to be feared of being doubted. Actually, because if you look at the past, if you doubt certain norms, you are sometimes jailed. That's how history is. But he said, no, it's our, and to demand this freedom as our duty to all coming generations. So research is something you have to doubt the fundamentals that you have, and through that you want to create something new. Now, the point here is like, if you want to create something new, you should understand that what you have is not adequate. Otherwise, you are not going to create something new. And this comes from Arthur C. Clarke's 3 laws. He was the chancellor of this university, late Arthur C. Clarke. He gave 3 important laws. Actually, you may go through this one carefully. First law says that you don't have to trust. When somebody said something impossible, don't trust it always. Think about it. Probably you will do something different. The second one is like, if you want to expand yourself, if you want to understand, you have to push to limits. Actually, the third one is very important. Any advanced knowledge amounts to magic. You are aware of this one, right? You see some of the modern technological development, you feel as if there was magic happening, but it's exactly the thing, nothing magical. It comes from basic fundamental sciences. Now moving on to film. This is Captain Barbosa said in Pirates of the Caribbean at the World's End. For sure, you have to be lost to find a place that can't be found. Elsewhere, everyone would know where it was. Let's see whether. I wanted to play this one, but it seems no sound, nothing. That's what he says. Any development I would have done. So, but the point is, what Barbosa said is very important, although it's hypothetical character. He says, like, he said, basically, for sure, if you are lost, then you are going to find new thing actually. That has a very high impact on what we are going to talk actually, because if you follow the same traditional way, it's highly likely that you are not going to end up in new things actually. So you have to think out of the box. This is what I want to tell actually. So move on. So what is this old knowledge actually? So we talk about new knowledge actually. So there should be old knowledge. Old knowledge is well documented. We are aware that you have books, you know, you have CDs, DVDs, and all the things are well archived and well known, and they are tested and verified. No problem with old knowledge. People know that where you might go wrong, and they already give remedies for that one actually. Now this old knowledge is actually gradual. It's a consequence of gradual development of scholarship. Like for 100 years, probably not more, probably 1,000 years of knowledge is archived properly. That's called new knowledge. But now as students, so researchers, actually, you are seeking new knowledge. Now the point is, if you want to say something is new, you need to know what is old. In other words, actually, unless you master what is known, you can't seek new knowledge actually, because it's contradictory. Unless you know what is in the past, you can't say something this is fairly new actually. So this end actually, you require so-called courseworks actually. So Coursework is basically a set of fundamental but advanced tools, technologies designed to cater for this all knowledge requirement, just to nurture a student with all knowledge. Now, this is well documented and you have many examples. And typically for the convenience of delivering, you arrange them in modules. For instance, sometimes they are freely available. If you go to this MIT Open Courseware, I'll just click this one just to, hopefully it will go there. Yeah, you will see. It's open. You can just go there and seek all the courses. Whatever the course you like, you can check there. And then Stanford Coursera, similar kind of thing. You can see there are so many universities affiliated with that one. And I'm sorry, this don't show up, but there are so many courses here. You can freely learn subject of your choice. So you see, people understand the value of coursework. So they went ahead and they archive them and they make it available for public to view, review, make use of that one for their knowledge gathering as well as development. So this is basically what the coursework is. It's basically archived knowledge, well documented with many examples and arranged so that people can master the art. But then you may wonder, I mean, why on earth you have to learn? Why do you want to know? Of course, you need to know all past knowledge, but why exactly? Actually, to improve the breadth and depth of the researcher or the research student. Now, what is breadth actually? Breadth is very important nowadays because nowadays research are becoming more and more interdisciplinary in nature. Back in the day, actually, you are in your own sphere, but now you are you are conducting research in the interface of many other sciences. So it's good to know other sciences as well. So that improves the breadth. And if you go to depth, actually, as a researcher, you want to analyze some problem and gather deep knowledge actually. So to facilitate acquiring of deep knowledge actually, the courses should be with sufficient depth as well. Now, what's the advantage of taking courses? I have listed, I will not go through each and every one carefully, but you see, it's going to generally give you an overview of what is known and what are the salient points. And going through the courses actually, you sort of build your confidence. So you feel confident that, okay, you know, I know a little bit of past knowledge, somewhat, and equipped with this knowledge, I am more than, you know, I'm confident to face that. I'll see future, unknown future, for your researcher. But at the same time, very important thing is you understand the limitation and the scope. What are the limitations of the archived knowledge? That's very important. Sometimes you call research gap, you can easily understand actually, you know the archived knowledge. When you archive knowledge, actually, the next immediate question is, what on earth can you do to overcome the limitations? And now we are in the sphere of real research. Now, then you are into so-called real research. Now you understood that there are limitations, but you have confidence built that you are confident that you know somewhat old knowledge, carefully you study. And now you know there's a gap actually, there are limitations, scope is different. Now you want to improve this one, right? It can be anything. Probably you try to make production line very efficient actually. Otherwise, it must have been very inefficient. So you want to do something new actually. So keeping this thing in mind, actually in the universities, typically they are where you do thesis, research degrees actually. You undertake certain research projects. So research project, or basically type of thesis, I would say as an outcome, can be classified into, broadly classified into these areas. Again, I will not go through each area, but you can see there are several areas. So the first one is like open up new areas. So maybe your research topic or your project may open up new areas that people have never knew earlier. So it's like we call it seminal research, seminal work, okay, groundbreaking work. Or sometimes, yeah, what you're going to do is unifying framework. You're going to introduce a framework actually, so that the posterity is going to be benefited from that. And once you go through carefully, you can see experimentally validate, produce an ambitious system, superior algorithm, new methodology, new tools, and everything. Now you can see one thing is, you are going to find something new actually. Always you are going to find something new. Okay, you are going to do something new. So you may be at some point in your life, you will be doing research, or you will be doing a project which falls into one of these categories. So probably blurred sometimes, but you can fit into several categories. And then if you want to get to the bottom of the problem in the research, so now if you are a researcher, budding researcher, I would say, that means you are starting your first career as a researcher, postgraduate degrees. So what should be done? So before you go to the bottom of the problem of your research problem, you are supposed to do something. So I can divide it into three parts, actually: building confidence part, and then you are going to boost your confidence, and then the final challenge. Now, build confidence. Actually, you should feel like President Obama said, yes, we can. First, you have to feel that you can do it. And to feel that you can do it, the push, the potential that you gather from coursework is enormous, actually, because you have worked out all existing example, very complicated questions you work on, and now you have confidence. But yet, you have confidence on archive knowledge, but not about new knowledge. Now, from archive knowledge, how would you go to new knowledge, actually? So the first one is no free lunch. So you have to work really hard at it. There are no simple solution, no magical formulas, nothing like that. You have to work hard at it. So as an initial thing, what you are doing is you have to reproduce existing results. You as a student, you try to read a paper or something very important related to your research, and you try to reproduce the result given. When you try to reproduce actually, you understand you cannot reproduce at once. Then you go deep now. Now you are going to dig it out. Why you cannot? Now you are in the learning process actually. Now what you are doing is you have a problem. So you try to decompose the problem into small parts actually, because the original problem you may not be able to solve. But once you decompose actually, the problem becomes simpler than earlier. This is called divide and conquer method actually. Or otherwise, what you try to do is that you take a toy problem and try to play around it. When you play around toy problem actually, although it's far away from your real research problem, it gives you so many insights actually, probably from numerical simulations or probably from numerical calculation. It's going to give insights actually. Through these steps actually, although this is not an exhaustive list, you are going to build your confidence systematically. It's an incremental development actually. But then you move into boosting confidence stage. In this stage actually, you further develop, you keep thinking what you have found actually. So you are gonna make thinking patterns actually. You're going to make hypotheses actually. And then you're going to move into generalizations and abstractions actually. Now, what does that mean? Basically, you get particular instances by doing simulation and analyzing data sets and everything. You get particular instances of no general problem. So now you relax your assumption, you relax your constraint, and try to generalize and make abstract modeling. You try to enunciate something through your abstract modeling. Through that, you push beyond the limits of available tools. And the third stage, I would say, grand challenge stage. That's calling the shot. Now you take over the research, and you are the boss now. Now you develop independent thinking. Now you can see a given problem, you can see different facets of the same problem. As Barbosa said, if everybody had followed along the same routes, actually, you would not have found a new place actually. So you want to see different facets of the same problem. But then you may find something, but you don't know whether it's novel or not. Well, what we do is we benchmark with the state of the art. So where do you get the state of the art? Well, that's why you have libraries, you have databases, you have so many things actually. So you look at them, you benchmark your result against what is known norms. So that way you can verify that whether your results are novel enough or you are on the correct direction actually, because otherwise you can again come back and you can correct yourself. But remember one thing very important, you have to be quick and you have to be flexible. Because you may start with the research problem having many expectations in your mind. As you move on, you'll understand you are not going to solve all the problem in one night or doing one thesis. You are going to learn it, but then you have to be flexible, but be quick. You are not the only researcher in the world. Other people are also working on the same topic more or less. So you have to be quick, but yet flexible. Now, the latter part of your research thesis is basically documentation and dissemination. I mean, this part is very important. So I got this small fragment from some French philosopher. He said, I would have written a shorter letter, but I did not have the time. Now see the idea behind it. So that means if you write a lot, that means you probably don't understand what you are writing properly. So writing succinctly something, concisely, it requires a lot of time actually. So you may wonder why you have a document and why you have to spend time on documentation and dissemination. Well, you may see there are several points I put. I just highlight salient point. The preserving knowledge is very, very important. Preserving knowledge is one of the most important things that we have undertaken long ago. Actually, we are nurturing the knowledge. We preserve it for other people. So we are benefited from our previous researchers. So then you learn technical writing. Actually, technical writing is not exactly the same as regular writing a book or writing newspaper. There are salient differences actually. Sequential language, notation, consistency, reference styles. I mean, there are significant differences that you are going to learn through process. And once you start writing, actually, you feel that you can organize concepts, and you look at your output, look at the material, you can create new insights. Actually, most probably you write something and you present it to your peers, your colleagues, through seminars, colloquia, and then people will give you critical comments. Actually, that critical comments come to you, and then you try to analyze this critical comment, and then you deepen your knowledge more. And towards the end of your thesis, though, what you should do is you have to claim your ownership, probably through publications or probably through patents. So I am pretty much familiar with publications, so I'll focus on publication, but it does not necessarily mean other things are not important. They are very, very important actually for the progress of this human society. So actually the publications are pretty important because it goes through so-called peer review process. So you find something, and according to the best of your knowledge, you believe that that is novel. That's fine, nothing wrong with that. But then you send it out, write a publication, very nice, and then you send it out for expert reviewers. So the expert reviewers are basically unrelated reviewers. They go through your things and they give you very critical comments. Very, very critical comments they give. Probably comments are detrimental, probably they are constructive, but you don't have control over it. Whatever the comments they give, you should look at them positively, and then you improve your piece of research work or piece of writing and stuff like that. But it culminates with so-called publications. Now the publications are very, very important for society, for universities, for entirely in the world actually. So if you are a scholar person, so you do thesis, the natural thing should be publications. Actually. Now the top publications are called Part L1, Q1 publications actually. These are the very important publications in the world. You can talk about Q1 publication with anybody in the world, with your colleagues and everyone, because they also know the value of this. They know the process of having Q1 publication. How hard is it? How hard it is actually, the way to do it, and the discipline that you develop through going through this publication. One of the most important thing I want to highlight is reproducible research actually. Reproducible result. So you may have done research and you may have produced result, but probably another researcher may or may not be able to independently reproduce it. But then your result is of little use. Okay, they will doubt your result. It happens in the human history. If you dig out, you would have seen like scientists claim some very strange results, but when other scientists try to replicate the result, they find that that's not going to work. Okay, so reproducibility of research is very, very important thing. So that's why typically in the papers you do softwares, data sets, and everything, you make it publicly available. Okay, so at the end of the thesis, you understand one thing: you learn how to do research. Okay, this is what you're going to understand. Now, around good things actually, there are popular myths. They have been around for ages actually. So I have listed a few myths actually. Well, I will not go through each and every, but the first one is very important. I do not have previous research experience, and therefore I will not be able to. I won't be successful in postgraduate research. I mean, it's a popular myth. They think that unless you know something a priori, you are not going to do something. Actually, that's not true. People are. I mean, in the panel discussion, we can take up this questions actually. It's not that you had previous experience. It's a continuous gathering of experience what matter knowledge actually. Continuous gathering of knowledge. That's what matters. The second one is advisor is stronger researcher than me, so I always need his help to solve my research problem. That means advisor is like a god. He knows everything. Well, if advisor knows everything, no point of hiring a student to do research, right? Well, advisor is certainly experienced and well versed in research than yourself. That's understandable. But the point is, you are the person who's going to do research. Advisor is going to help. So you are the person who's going to crack the research problem. Okay. So the truth is, you are the person towards the end, as I said, you can call the shot. You can call the shot because it is your research, not advisor's research. Of course, it's a part and parcel. Chemistry should match, but it doesn't mean that Advisor is the expert. At the end of the day, you should be the expert. That's why your research is. So the third one is fundamental researches are of little use to the society. Some people believe like doing fundamental research versus applied research. There are arguments actually. We can take up this thing in during our discussion. And then about thesis writing. Some people think like you have to write a massive thesis to impress the committee, but that's not the idea. The idea is thesis should be short and sweet. Actually. It's a self-contained document. Not only that, it should present something in a manner that the reader can understand, and one day he should be able to make use of your result for the betterment of the society or for the betterment of even society. So, I mean, this is the end of my talk. So I try to scratch the tip of that massive iceberg. And thank you very much for listening. Thank you.
Yes, all the effort is worth it. Yes, sir. Thanks for informative presentation. So you discussed many important things on coursework. How to choose the relevant coursework?
So actually depends on the advisor and your agreement. So you look at first your research. I would say first you look at your research problem, and then you look at the periphery of research problem and see what are the overlapping areas. So what's the knowledge component that you should learn, and then you look at your previous knowledge, bachelor's knowledge or basically your diploma knowledge, to up to which point have you completed this knowledge, and what's the knowledge component that you require. I would say skill set, and then you understand the disparity, and then probably you choose courses according to your requirement. So that's the answer. Chandra, can you add something?
So then, how credible are the online courses? Then you discuss many things and you.
Yeah, I think we asked from Chaturanga. What do you think? You can comment about that.
Can you hear me?
The credibility of MOOCs. I mean, knowledge is available, but we don't know the quality of the knowledge.
Yeah. Actually, if you Google for, I mean, suppose you want to, can you hear me? I believe you can hear me. Okay, thanks. So there can be many sources. Okay, I mean, once you Google, for example, I mean, just imagine I'm talking on behalf of my kind of expertise. So wireless communication, you Google, you can have plenty of places, but there are so many places students find it difficult to pick, okay, which one is most kind of effective after going through. Okay, I mean, there are many. Out of those many things, you have to pick one. Okay, so one of the kind of sanity check, at least I was using myself and kind of recommending for the students. I mean, you can see really what is the source. Okay, as long as the source is coming from a kind of proven place. Okay, proven place mean, I mean, everybody should agree. Okay, the powerhouses in the world. Okay, the maybe best top 10 universities. Okay, Stanford, maybe Berkeley, Harvard. If you know that something is coming from that place, okay, I mean, this kind of sanity check that you can have. Okay, who is the kind of the presenter of the course, or the YouTuber, or the place where he's kind of working. And this is one of the main kind of check that you can see, okay, this is good. Okay, so then again, you should kind of think, okay, the sources are credible from good places. So listen to those credible places. As long as it is coming from a powerhouse, usually these are going to be very good. Okay, this is kind of that's something that I'm practicing. I don't know, maybe some other thoughts, Pratap and Minha.
I think my thought is basically given subject. Always in the world, there's an authoritative figure. There is authoritative text actually. Basically, advisors know these things. So you have to seek information from people like them because their knowledge is tested many, many, many times and heavily criticized. Likewise, they are very pretty much shaped. So you have to go for authoritative texts and authoritative authors, authoritative teachers because they know the subject. But it doesn't mean they are always correct. But their knowledge is well structured and well disciplined. So it's good to start from them till you get your independent thinking and you have a resolution about what is happening. Yeah, that's my answer.
Yeah, so actually I agree with you. But the thing is the time management. So no, it's very difficult to manage our time for coursework, isn't it? So then how do we invest our time meaningfully in coursework?
Yeah, actually, I believe That's a good question. But time management is basically as a research student. More often in Sri Lanka, actually, you are not supposed to do tutorials and assignments and marking papers and stuff like that. But other countries, like you are supposed to do TA business. So teaching assistant. As a part of that, you have to take time for teaching management stuff and paper marking and stuff. But then you have time for yourself. But then the first thing you can do is that you can not start research right away. What people do is you focus on your coursework more. But then to get maximum out of coursework, what you should do is basically you have to work out problems. You have to work out problems. You have to recreate the knowledge, known knowledge. You have to work out problems and use cases or case studies. You have to go through them carefully and you have to do this one. But in the time management is basically, it's entirely up to you because as a research student, you should focus on the things that are of paramount importance to your research, not other stuff. So as a human lab, you have 24 hours. And then since you don't have teaching responsibilities and stuff like that, I would imagine that as a student, you have quite a plenty of time. If you're a part-time person, actually, that can be a critical problem, I understand. It's part of your work. In that case, actually, you have to somehow squeeze in time from your busy schedule, at least to study as well as doing exercise. Unless you do assignment, you are not going to master the art because knowledge is always third hand. To make it first hand or second hand, actually, what you should do is you want to make sure that you do assignments, you spend time on assignments, and you get the intended result. If not, you have to argue continuously and try to go to the bottom of this problem. And this way, you can create the knowledge. But your question regarding the time management actually is a critical problem. It is a personal dependent because some people can understand things very quickly, whereas some people cannot. Some people are quick thinkers, whereas some people are not quick thinkers. It's an extremely personal thing. Yes. There's no known formula to say that this is the formula you plug in and then you're going to get. Yes. But it's a heavily personal. But I think your guidelines, beacons should be like you wanna learn from the courses. So you wanna work out examples, use cases, case studies. You wanna work out carefully, so you have to somehow get time for this.
There is no mechanism to follow.
I don't think there is, say for instance, to write a PhD thesis, even there is no known mechanism to say this is the way, but there are many ways.
Yes.
The same way, actually, time management is entirely up to you.
Yes.
It's a critical thing, but it's entirely.
Yeah. Thank you so much. Yes, sir and matters. So research is a process, I think. It is a long journey to work to meet our objective with more difficulties. So then how should we make it first move in research?
I think probably you can understand how to.
So I think so when we consider the research process.
So I will start the first move. Probably I will start. As I said earlier, the best way is to check the what's called available knowledge. When you start solve problem. So I was once listening to Bob Gallagher. Robert Gallagher, everyone knows MIT electrical engineering. He said there's one famous person called Shannon, father of modern information theory, one of the famous scientists, late Professor Shannon. So Gallagher had a problem. So Gallagher went to see Shannon and asked the problem. Shannon said, "Oh, this problem is too complicated." So then he gave problem to Shannon. Shannon was a very famous scientist, right? Information theorist. And then what he did was very simple thing. He took the problem and said, okay, let's relax this, relax. And then the problem boils down to very small problem. I would say simple problem, simpler than the problem. And then he could solve the problem. And then he went on adding all other ingredients. And then he said, oh, surprising, miraculously, I got my problem solved. So the first thing I strongly believe is you have to start with the toy problem. Analogies are very important, but start with toy problem. So if you start with the most difficult thing under the sun, you'll be frustrated immediately and you'll give up research. So this is my personal experience. So you can share something with your experience with Dr. Min.
Yeah, here I can share some of my own experiences. To be honest, I was not quick in research. And then what happened to me is that for a long time, I couldn't find topic. And then finally, I decided I have to do something. And then I started reading the papers, and I did exactly what was used by Dr. Patel. And I just first try to reproduce what others have done. But I have found that in some work, they have suggested that something has not been And that is typically, but I just did the numerical results. And for me, for the new part, I have no analytical result, but I just did some simulations. And I found that there are gaps. Okay, there are a set of curves. And there's then for the new problem, it has no numerical, no analytical solutions. So I did simulation first. Then I found based on my previous readings, okay, I feel like there should be a method which can connect the high end in our area. There's low SM signal to noise ratio. There's some results, and there are another set of results. Basically, there are special cases. Special cases sometimes are easy. Okay, like limit. You take a limit to either one limit and the other. I could see two limits. Okay, but the middle part I don't know. So what I did is, based on simulation, I understand something should bridge these two limits. Then I eventually, then I go back to read more books, okay? I earlier read a lot, but reading is never ending. Coursework you can always do, right? But at a certain point, you have to stop and do as well. This is related to what we discussed earlier. So when I started doing, and I found the gap, and eventually I read more to figure out, okay, again, I went back to read other people's paper more carefully, step-by-step derivation, and eventually I could solve the problem, which was believed to be difficult. And that came as first a conference paper, and eventually it became a journal paper as well in Q1. So this is my experience, like how to start. First, what I did exactly what Dr. Pratap said. First, you read other people's paper, and then you do simulations. People say this is hard, okay? And I also believe it's hard. I didn't trust myself. But then when I do simulation, I found the two limits, which is like toy problem on each end. And then, yeah, I eventually bridged the gap and provide the result, which works for both ends as well in the middle. Because basically you have to solve, in my case, an optimization problem. Yeah, so this is my experience.
Dr. Chaturanga.
Okay, so okay, I think what Minho and Patapa said, okay, I certainly agree with them. I would add a little bit from my side. Like I remember just after I started my PhD in 2007, so I was spending time reading papers out there. Okay.
Chaturanga, I think
Yeah.
it was the best PhD research in there, isn't it? Your research?
Oh, it's something. Oh, yeah, in that particular year. Okay, it turns out, but I was kind of sharing what I had a very tough time at the very beginning. Okay, the tough time in the sense my supervisor say, okay, this is the area you have to work on. Read these papers, bombarding with so many papers. Okay, so then again, I cannot rely on him. Certainly, I had to take the handle to myself. Okay, so then I will start reading. I start reading those papers, and it's like just wandering here and there. No kind of handle to start from this point. I start working on. From this point I'm working on. Again, I'm reading papers. Okay, I see some kind of I don't know whether you are aware of these things. Optimization kind of stuff is in this paper. So many new things, but skipping those, still trying to digest the content of the paper, and maybe 6 months kind of then I had to kind of stop. Okay, kind of frustrated again. So there's what is the most missing part is the courseworks. Okay, so then one of the nice person and reached me is Marian Codriano. He said, you cannot do like this. Take this particular course and master it. And he asked, okay, how long you need to know? How long you need to spend on this? I say I can spend 1 month. It was a course related to optimization theory. I said, okay, I'll spend 1 month. He said, no, I will give you 3 months. Spend 3 months in this particular course, and then we start talking. He said, then we have a common protocol, and then you start seeing that what are the stuff that you are reading in the papers, you can match the thing, you can match the links, you can start interpreting the stuff, and then you can have a holistic view. Okay, now you start building up the general knowledge and the experience and the confidence, because you start feeling that when I'm reading the papers, I'm kind of collecting the ideas, key ideas I can easily grab. So the missing part of the courseworks. Okay, so I start doing that particular course for 3 months. My estimate was 1 month. He said, no, We had to do it with exercises. Take 3 months and do it, and then we talk. Okay. So that's kind of the way that I was kind of first move in my research, wandering, but it didn't work. Okay.
Thank you so much. So then, my next question actually, so when we discuss research, so impact is very much important and relevant word that we use to discuss the research experience, isn't it? Impact, research impact of the research output has this. So what is the impact of previous research experience? You all discussed about your previous experience in your research journey. So then, what is the impact of previous research experience?
I think if I answer first, I think the previous research in the sense, I believe like from the student perspective, though, you as an undergraduate, sometimes you get a unique chance to engage in research with senior students or probably faculty members. So some people have this kind of experience, whereas some people don't have. Now, if you have this experience, the advantage is you are aware of the research sphere. Um, what, what are the norms there? What are the traditions there? So how to approach something, how to get something done. So how to read papers. So if you look at carefully, even newly admitted graduate students, probably they are not aware of which forum to check for information. As you said, I mean, there are so many forums. If you have Google Word, I mean, millions of places come. But where are they? So it's like time consuming. If you try to go through all pages, it's time consuming and you're frustrated. So if you have a prior information about these things, working with some good researchers actually, it's a really advantage. The previous research experience in that way is quite advantageous once you go to postgraduate research. But it doesn't mean that's not a bottleneck actually, because you'll not be discouraged saying that, as I said, one myth. The first myth I said is like you need to have previous research. No, you don't need to have. But if you have, actually, it's an added advantage for you to move forward. Yeah, that's pretty much it.
Yes. Then, actually, so then after researching that, so then we should present our research contribution, theoretical contribution, methodological contribution uh, in our research output. Okay, so then in front of the panel, we have to discuss these things. These are our research contribution, these are our methodological contribution as well. So then, how do you assess the novelty of?
Okay. So novelty of the contribution, certainly you should have a very good understanding of what has already been done in the particular area. Okay. So without knowing that thing, I mean, needless to say that you can say something about the novelty. So that you keep reading one paper after the other paper. I mean, then you have a fair enough understanding of that one, and then you can say, okay, in what sense that my work is different from those or work which has already been kind of published in the area. Okay, it may be you can isolate. Okay, my one is good or new. I have maybe relaxed some of the assumptions here. My one is new in the sense that my one is a general framework that captured so many things which are not captured by the other models. Okay, my one something like that. I mean, certainly you need to have a benchmark. Okay, you should need to know the state of the art. So reading many papers together with the expertise, your supervisor, maybe your advisor, you had to kind of, unless you cannot tell something, okay, this is my new things, certainly you is something that you get that kind of understanding after reading many things, okay, in the area. So that you had to understand, and then you need, okay, this is something new which were not addressed in that part. Okay, now is something to be publishable. Okay, maybe again you can show that your results, okay, to someone else or to check whether it is good or bad. I can share one of my experience again during my research. Okay, I was spending several months of something, and I start feeling that it is novel. Okay, within the reading the research of the areas. Okay, my advisor is there. We were discussing. Myself and my advisor feel that okay, this is something really novel. Okay, then what we did, okay, we present the results to one of the professor came from USA. And when we were presenting him the work, he said, your problem formulation from the inception doesn't make any sense in one of the problem that we are working, okay? So that means even we have felt that it is novel within our small understanding of the areas, even with reading some of the papers, but there was something that we were missing. Okay, so when you are assessing your novelty, certainly it is good to have kind of brainstorming session with other ones as well, because it is good to okay, if it is not novel, it is good that it is pointed out by one of your colleague rather than someone from the review panel out there. Okay, so certainly these kind of good discussions with other people also kind of give kind of assessments how novel is your research. Okay, so that is something that I can share.
Okay, thank you. Now I would like to open the floor for our students to raise any questions you have to our eminent panelist. So I'll check the chat line.
There's one question I can see here. One person, I'm doing your job anyway, since I can see. It is difficult to complete a PhD with the publications in reputed journals within small time. You please giving advice to reach quick publications. Also, thank you very much for valuable information shared with us. Thank you very much, Kimhani. I looking at this question, actually, this has been around in Sri Lanka for quite some time. Actually, always I see this one. PhD is kind of a doctor of philosophy. It says doctor of philosophy, it's not bachelor. Doctor of philosophy, you are supposed to develop a philosophy. So if you are supposed to develop a philosophy in the sense like okay part of that, then it's highly unlikely that you cannot get a publication. Why cannot? Should be able to do it. Actually. Remember one thing, as I said, there is no short formulas. There are no Maggie noodles here. 1 minute noodles are not here. PhD is considered like 5 years or something, more or less 4-5 years actually. During that time period, actually, you have to develop your independent thinking and benchmark you with other people. And then I cannot see any reason why you cannot, not you particularly, it's a general question, why you cannot publish in reputed journals. Because if your research project is up to international standard, that's a critical thing you have to think. First, the problem should be of good quality. As Dr. Chaturanga said properly, if the problem has already been solved, but then probably you are not aware of that. But if you don't aware, does not necessarily mean it is new. This is a critical problem. That's why you need coursework requirement as well as read literature continuously. So if you identify research gap properly, and if you cater for that research gap according to the science that you know, papers should be natural in my frank opinion. I mean, this is what I can say about this. So I don't agree with the argument small time, because PhD is a long time process. It's actually 3 to 4 years, I suppose. So it's a long time process. It's almost like a bachelor degree, entire span of bachelor degree. But you are focusing on one topic. Bachelor degree, probably you have different subjects, but here you are creating deep knowledge in one topic. Actually. So there is no advice to give exactly how to get quick publication. Well, there is a way to get quick publication, which I have seen around Sri Lanka. You pay some money and publish. But the problem is these are not prestigious fora. So if you want to go for prestigious fora, first you should be able to read a paper from that fora. Say, for instance, if you want to publish, say, some analysis of some journal, so first you should be able to read from that journal. And then only you match your ability with the content of that journal. And then your research should match the expectations of that journal. But if you do research carefully enough and you identify the problem, well, I cannot see any reason why you cannot get a publication. Not you, I mean general. But other people can also add some. If you wish to add that. That's my own opinion.
Yeah, I think if you have done something that really that you can see, okay, there's a real contribution here. I have seen in some of the documentations as well. If you see that what you have done is super duper, it can be easily documented. And when you are writing your contribution, it is damn easy to write the contribution. But if you have done something not super duper, something vague, even you cannot say what is really the contribution, it's very hardly you can write even the contribution part. Okay, you have to just mumble there. So you find it difficult to isolate even. So if it is the case, kind of advice is to harder, work harder to further investigate a problem. Okay, find a new problem, and that means you are not still matured enough to publish the result. Okay, or maybe the result is not certainly. But unfortunately, the thing is, in very many forums, we label those as predatory conferences and journals. Okay, so there are very many places that you can still publish these mumble jumbles stuff, but still those are going to be accepted. So this, as a PhD student, for you, in terms of the learning process, gives you nothing. For the university, in terms of ranking, gives nothing. For the system, it gives nothing. But some short-term benefits like a label, of course, then you can get the label. But for some reason, even students are in a kind of dilemma, what to do and what not to do because of the system. Sometimes I can understand, okay, because of these predatory journals. I mean, people, you can see, okay, your colleagues are, I have a personal experience with one of the lady in Slate who was doing kind of a research with me. I quickly share this story. So then she had a tough time, okay, because she see that her colleagues are publishing one paper per 1 month or something like that in journals, okay, but roughly speaking, predatory. So the problem is then the student who's working with me has a pressure. Okay, so these guys are publishing. Now they have spent 2 years, they have now 3 papers, 4 papers, but I have no papers, okay? So I have a hard time to even report my progress. So, but why is that? Why my answer was, okay, is that means your research is not matured enough to be published in a Q1 journal. That is the main reason. So anyway, so these things are there, okay? But she worked hard. She worked hard and managed somehow to publish in a Q1 journal based on what now she got a PhD position in KTH, Royal Institute of Technology, okay, with a very high good salary. So it pays off somehow. But if you want to stay in kind of a small pond, locally optimal, I mean, then certainly that approach might be useful, but I don't think it is a kind of recommended in my opinion. You can't, there's no free lunch as Pratap kind of pointed in his presentation. You had to work hard, otherwise simple, I mean, problem is infeasible. This is my kind of feeling. Thank you.
I think another,
Thank you, sir.
I think Professor Ajit has a question. Do you think of taking coursework data from MIT Open Course, etc., as part of the coursework requirement by another university of the PG degree? Actually, Professor Ajit, I don't think it's the correct way now. If you go to these universities, because I was in one of these universities, I was in Stanford University. And if you go to Stanford, their PG courses are pretty much standard, and their faculty members teach these courses. They come there, they teach, and they share their resources. I mean, they share their knowledge and stuff like that. And still, they have taken these courses from other places like online resources and stuff like that. But online resources, I always believe, is for checks and balances. Always you need to have a teacher with you just to answer the questions, to discuss, to get, I would say, expand your horizon. There should be a teacher. There should be an organic teacher with you. I mean, that's what they practice in that part of the world. Never mind what knowledge they have, archive knowledge, still there's an organic teacher there. The organic person teach them the archive knowledge carefully, and the students organically understand. But yet, they refer to this all courseware and everything for their personal improvements and stuff like that. So I don't think, my personal opinion is, I don't think it's a wise idea, but certainly we should make them available for people to strengthen their knowledge and enhance their view on subjects. Certainly they should use, but I always believe that there should be organic teacher who's well versed in this subject to teach. That's my opinion. Probably other people have their own diverse opinion.
Let me share a little about this one with my experience in Oulu when I was doing PhD. In that case, the organic teacher case is really important, as Pratap has correctly pointed out. Organic teacher, for example, I wanted to take a course in mathematical optimization and two levels, level 1 and level 2. I mean, level 1 is roughly speaking kind of main fundamentals, and level 2 is a little bit more sophisticated stuff. So then there were no way that I could take it within my department. So then I was given the opportunity to talk to one of the lecturer in mathematics department in the University of Oulu. Then I talked to him. Then he said he's the organic kind of this, according to the label given by Pratap, he's going to be the lecturer, but he cannot do lectures just for one student. So he said, this is how it goes. He made the schedule. He made the schedule and he asked me to follow the Stanford lectures from Stephen Boyd. And assignments were set by this organic teacher. And assignments were marked by this organic teacher, and he know where to pitch. Okay, according he know what is taught by the Stanford, and he know the basics. He know what kind of assessment he should provide with me, and even the examination was set by himself, and the projects, whatever the related projects associated with this particular module was set by himself. So then I had to report everything to him, and he's marking, he's doing the assessment. So under this one, he didn't do physical teaching to me. However, he was always monitoring what I'm doing, and he gave me just go and listen to those online lectures, and whatever the difficult parts, I had to go to him and talk with him, and then discuss. So in a way that the online courses offered in powerhouses were integrated into the system through some mechanism. So this is what I have observed here. Such a thing, if can be done through this kind of a, how to say, qualified person in that area, so the cross and balances should be there. Otherwise, students is again going to be kind of lost. Okay. So in that setting, I think still it can be a kind of possibility. Thank you.
Thank you. Some student asks.
And there's another question actually. I got this one. Can you elaborate the importance of the use of simulation along with experimentation in the research work? So I think if you look at carefully nowadays, because of the advent of computer technologies and everything, more or less actually you can easily, somewhat it's easier to analyze numerical result or generate numerics or run simulation faster than getting closed form solutions, closed form results, analytical results. So therefore, simulations are very important. Simulations are part of very important thing right now, because some time ago it was not the case, and people deriving so many analytical results. There was a reason, because those days computers were not developed and computational power was low and it was expensive. I would say not as cheap as right now. Because of that, they rely on heavily on brain power and they wanted to do anything. But right now, actually, the computing power probably is cheaper than earlier, and there are much opportunities. So because of that, actually, they go for simulation and the experimentation. Some research are based on experiments. Actually, as we said, this I can't go to this. Actually, yeah, this is probably, yeah. You can see here there are some are basically experimentally validates theory. These are very important thing actually. So you need to use simulation as well as experimentation in some research. But the problem, there is an inherent problem, not a problem. I would say it's an inherent characteristic of that kind of thing. So if you run a simulation, so you ask computer to run a simulation but you run a simulation for particular scenario. It's a known instance. So you have to fix parameters. You have to give numerical parameters. You have to feed parameters. For that set of configuration of parameters, you are going to get results. But then when you change the set of parameters, probably you are going to get another set of results. But then sometimes it's very hard to generalize what you see. The trend from sample to sample, instance to instance, you see trend, but it's very hard to generalize the trend actually by looking at simulation. But certainly you can understand something. Certainly you can understand something. Experiment is the same. Experiment is the same. I mean, you can run experiment keeping some factors fixed or some standard process. You can run experiment. Sometimes probably out of experiment, whatever you see is the result that you have been searching. That's understandable. But if you merely do simulation for a thesis, probably it can be the case because it's very hard to analytically tackle down the problem. There's no problem with that. But the thing is, you have to take extra care because sometimes numbers are misleading. Sometimes numbers are misleading. Probably general philosophy behaves in a way, but when the numbers are crunching together, actually, you are going to see something different. So you have to be a bit of careful actually when you purely use simulations. In the experiment, you have to be careful actually when you take experimental data and how you handle data, because we have a lot of data, but what matters is quality of data. So you run experiment, then you gather data. I would say observation. Then you take observation, you tabulate them, or you analyze observations, or then you are going to create conclusions or inferences using that. So then you have to be extremely careful actually, because if something went wrong underlying, probably your data, you get some superb results, and you will see that you found something magnificent, some remarkable thing, but turns out that your experiment or your simulation underneath there's something wrong. So first you have to calibrate. If you run a simulation, the first important thing is you have to calibrate your simulation, your setup against known setup, and you see whether you get the known result first as a degenerated case of your setup, and then you go for unknown case. But sometimes I have seen students, they run simulation and they come up with solution and say, wow, I got like 3 dB increment, like in our area set. So then you question it. Well, theoretically it cannot happen. What happened? Well, once you dig out, then you see that they did not use proper parameters. So their model has something inherent, some mistake, but they could not detect because they did not calibrate it against the non-norm set. Now you see, at this juncture, again, the coursework requirements kicks in actually, because non-knowledge is very important. So you want to calibrate. When you take data, actually, you want to make sure that data is reliable data and stuff like that. So these are very important things, but then you have to take extra care when you do, because if you have analytical result, actually, then you can degenerate the result and see whether it works here and there. But when you have simulation results, actually, you have to be really careful enough. You have to be careful enough to make sure that your setup is well calibrated and it is capable of producing the known results as a degenerate case. But if it cannot produce the known result, then there is something wrong with your setup, and then you have to go back and fix it. Yep, that's pretty much what I can do. You want to add something, Chatra?
Yeah, maybe a little. I was listening to one of the lecturer, Stanford Mathematics, Gunnar Carson. He's a topologist. Okay, topology, one of the damn hard area in mathematics. And he, in his one of the presentation, he was telling deep learning. He was talking about deep learning. Okay, and he's telling, okay, so the thing is, deep learning, people, I mean, it's essentially simulation. I mean, you simply take a TensorFlow, whatever, and you plug and play, and you start seeing some results are coming out. And one of the main comment from Gunnar Carson from Stanford Mathematics is they lack transparency. People do not know what is happening inside. And he further elaborate, he said, the solution method cannot be engineered. Okay, that has a big meaning. He said cannot be engineered in the sense you can't see why it is happening. You can't see, as Pratap mentioned, okay, checking different, okay, under this setting, this is happening. You cannot see what is really happening. You have just a very kind of very superficial understanding of a system. Okay, some parameters. You see, you change some parameters, results behaving like that, or sometimes your super duper results. Usually this deep learning due to overfitting, as known by everybody in the area, okay, overfitting. So the thing is, you, no matter what, I mean, you cannot get some insights into the solutions or why your solutions are behaving like that, these kind of things. These are critical problems, okay? So the thing is, if you have an analytical handle behind it, certainly you can see what is happening. You can see if you do like this, what if you change like this, what if this model is going to be little bit, say, perturbed like this, everything. That is called the transparency. You can even tell in before in hand what is going to happen when you have a kind of proper analytical handle, which is not usually just if you run something based on machine learning or based on simulation, that part is going to be missing. Okay, but however, the simulation can give you some thing, as Minho mentioned. I can remember Minho just mentioned. Again, I experienced in my research. Okay, when I was doing run simulation, I start observing some behaviors. Okay, now when you dig into deep, okay, why this behavior, and you change the settings, and I mean you start seeing the behavior is kind of preserving or more general settings. Okay, then you start seeing digging. Okay, then then it is kind of a very, I mean, you should feel happy if you see something that, okay, something that you can prove analytically. So such a thing, if you know, okay, then you can trace to the required courseworks and the theories, and you can talk to the experts in the areas, and then you start seeing a proper tools, what is missing to analytically justify that particular behavior that you see in simulation settings. Okay, so that by itself is going to be a good contribution. Okay, so that's why simulations and theoretical, of course, I mean, there are pros and cons in both, but you can use them both in your kind of development, whatever your research career. Okay, hand in hand.
One of our students has posed a question. How can we think the time value of the data when we're going to publish an article? Reviewers take much time.
Ask it again, I didn't catch it.
How can we think the time value of the data when we're going to publish an article? Reviewers take much time.
Well, it's a good question. Actually, that's people understood this one. That's why they produce like non-referee archives, like archive. Something called archive is there. So I can show you this archive. If you look at carefully, and they have so many. You can see so many sciences, economics. I don't know about other sciences, but the sciences related to us already they are here. So what they do is there should be similar archive for other sciences as well. So this is like not peer reviewed, it's basically non-referee. So when you publish, when you send article for review, what we do is we upload this one on archive. So it is freely available for other people. So reviewers may take time and data value or whatever you call it may depends, but the permanent archival value of your document will not diminish in the space because it's already there. Already you claimed your ownership, and already there your contributions are already there. And your fellow researchers or your colleagues can easily refer to this one and comment about it and make use of your result and so on and so forth. So your question is correct. So the reverse take like my experience is like to get a Q1 journal publication completely done. It takes more or less 1 year from first submission to last appearance, probably more than 1 year. We call in the press. So that's why when PhD students actually you have like 4 or 5 years actually when you are halfway through your research, you start writing papers. Actually. Why? Because it takes time. Writing takes time, as I said earlier, but then once you send it to reviewers, typically journal lifespan is like 3 months for the first review probably, if you are lucky. And then if you are lucky enough, you get the second review, probably another 3 months, 6 months, and then some also administrative stuff, and it takes more or less 1 year, more or less. So to make sure that your research effort is not wasted, and what the impact that you want to have is you deserve the impact and you get it. What you can do is you can find this kind of archive and upload there. And researchers are ethical once you publish this one online and they know that you are the person that who wants this one. And I try to figure out anything, but I cannot find any. You can easily find papers here. You type a name, say, search. You see the papers. You see the papers. If you click here, I mean, this is just an example. I'm sure. Just click here. It goes to Displays Cornell Library, submitted 28 June 2022. You can see very recent. So this kind of paper, these papers have been submitted for peer review journals. It will take another 1 year. That is 2023 to let me, but right now it has been see. So this kind of open for us are there. So you can make use of this for us. That is the best thing I can say. Right. Yes. There's another question I can't see.
So there are some questions.
Yeah, I don't know. So here we go. Yes, Professor Ajit had used to getting grip with the research gap. We always suggest to read literature, but we do not direct students to check patent literature. Do you think these omissions we are missing? Actually, Professor Ajit is correct, but I cannot comment about patent literature because I am not aware, because in my research, throughout my research career, I never refer to any single patent because we have been doing kind of analytical research. But your point is correct. So if you want to develop something, a new technology or new tool, probably it's good to check patent literature. But I really am ill versed in patents actually. So how to get patent, how to open patent, how to read it, I really don't know. So I cannot really comment about that one, but I do understand it's important for a thesis which aims to develop a new sort of practical technology for the betterment. Yes, I understand, but really, I really I cannot comment about it. I understand. I agree with you. But for analytical research, it's hardly not true because all the analytical things are basically people already derived this stuff and archived well. More often, if you go through or archived things, you're better off as far as I know. You don't have to check patents. But for technological developments, probably right away available thing, probably you have to go for that. I cannot comment really. Then Upeka asks, I have a comment to make on simulation. There's one. Probably he can comment.
Yes, actually, there's something I would really like to comment regarding simulations because there are certain areas where, because now my PhD is in nonlinear systems theory, so there are certain areas where where the analytic model tells you a lot more than the simulation, right? So, for example, now if you were to sort of like get the analytic model or sort of like get the same result as the analytic model using simulations, you will have to run probably an infeasible amount of simulations in order to get the same result as an analytic model. And also there are certain simulations where you cannot get any interpretable result as well. Like the best example is the simulation of a chaotic system. If you simulate a chaotic system, what you will get will mainly look like random noise. So out of that, you cannot get an interpretable, or it's very difficult to get an interpretable result from simulating a chaotic system. But of course, there are also other areas, like for example, computational fluid dynamics, which mainly depend on simulations in order to validate their results.
Thank you.
Thank you.
Thank you. So then, sir, Dr. Pratap, then you discuss some important things under the documentation process in your presentations. Okay. So actually, documentation process is indispensable in research, isn't it?
Yes, yes.
Then how important is this?
Actually, this is as I said earlier, I have written here actually, it's pretty important actually, because ultimately how do you convince someone that you have done something? You can tell somebody, you know, I did the research and blah, blah, but nobody will believe it. Unless you document it properly, according to the pertinent standards, I would say, and present it to an audience. So how do you do it? Well, one way is to colloquia, seminars, or I would say conferences, or through journal publications. Or in other ways, the other way around actually, if you have technologies, you can go for patents. Some people write books, and there are many other ways of doing that. Likewise. Now, this is a pretty important thing because by writing something properly, only you understand if there are some problems with you. When you keep writing it, you understand, you get bird's eye view of your results, and then you can see like, oh my goodness, something is going on here, something is going on here, things like that. But when you write properly and send it to a third independent party like publication, I would be like, and then they get chance to read your mind in fact. But the problem here is you are not going to go to reviewer and tell them, pinching and tell them, look, I mean this one, this sentence, I mean this one, this one. No, you cannot do it. You have no clue. You have to express yourself through the language of your choice, but the language is naturally English because it's the wide acceptable language for this thing. So you need to write something in such a manner that the reader can comprehend what you have done. So this is challenging even to well-experienced researchers. It's very challenging to convey something to somebody. It's not an easy task actually. It's not an easy task. So conference advantage is conference you can argue with people actually, colloquial. You can colloquial argument you can do. But for a journal or high prestigious forum actually, the problem is you want to convince somebody. So you will see documentation very important. If you want to convince to a third party whom you have no idea who you are, and then you want to make sure that your presentation adequately reflect what you have done, your result, the significance of your result. the salient points. So you will see the language, notation, figure, table, reference, the way you use it is of paramount importance. Sometimes I have been serving as an editor for a journal, IEEE Wireless Communication Letters. It's a Q1 journal of IEEE Communication Society, one of the good journals having a high impact actually. I'm associate editor there. Now, very often what we see is from certain countries, when you get papers, actually, what's wrong is like, I mean, they cannot express themselves properly, but they have scientific quality is there, scientific merit is there, but the thing is that still it's very hard to dig it out.
Contribution is there.
Contribution is there, but you cannot figure out. You cannot figure out. I mean, it's like a very difficult task because their language is extremely bad, poor language. Now, this is a problem. Now, to overcome this one, you need to have proper documentation and dissemination methods. You need to learn proper language. You need to learn proper punctuation. You need to learn proper thing. I mean, if you go through carefully my presentation, you see, this is one of the things I want to highlight actually. You see, each and every figure, I have a citation. I mention source. I give proper credit. You see why? This is not, I mean, I would have saved this and I would have enlarged this picture. I did not do it because there's a reason. The reason is like, I mean, you have to give proper credit to proper authors, owners. This is one of the most important things actually. So you see, because of that, I mean, this is one instance that I picked up. So this kind of documentation process is of paramount importance because you cannot convince, say, after your death, probably still people will use your papers. I would say, now we are reading Shannon's paper. Shannon is no longer there in this world. At least acceptable sense in the world. Not religiously. So he's not there. But still we are benefited through his writing because he wrote in such a manner that we can understand. Imagine he did a very bad job. Even his knowledge is their precious thing, but people couldn't decode it. So this is the thing that the documentation and dissemination kicks in. This is very important. This is the place where you sort of show off your research. You showcase your research and say, look, this is what I have done. This is how it was done. These are my results. How significant? My results are significant, or my results are superior to other results. So to convince an unknown person, actually, you should learn writing and writing techniques. Actually. So there are technical writing courses and stuff like that. But the only way to learn technical writing is write yourself. That's how you can do. I mean, you have to write yourself. It's very hard task, but then you will master the art.
Actually, sir, according to FGS guidelines, so it is needed to have publication using our research works. So it's a very difficult task actually. So then, what is the importance of having that kind of publications?
Publications are important. Like if you plan to stay in academic career, if you plan to stay in the academia, actually very important publications. Now, if you see other sister universities around the world, actually, so university ranking heavily depends on publication, but not publication per se. Q1 publication. Q1 publication matters a lot. It's not publication per se because, as I said earlier, like you can publish anywhere. You can have your own journal. You can have your own journal. You can go to like literature journals. There are thousands of literature journals. You can easily get published. You can pay money and publish. I have seen people doing it. It's a heavy industry. Starting journals is a heavy industry as well as publishing in this garbage journal is also a heavy industry. You pay some money and get it published. But these publications will not add anything to you because your colleague from another university will have a look at saying that, oh, okay, this guy is publishing this forum. This forum is not acceptable to other people. So you have to understand when you publish it, you have to find the correct forum, which is my dissemination is Q1. Now, our FGS guidelines say publication. I think Scopus Index. I mean, there are so many journals in Scopus Index as per my knowledge. But I have been advocating Q1 only because Q1 only will define your university, define yourself. These are other people. Other countries actually you don't have this requirement. As far as I know, other countries you don't have publication requirement at all for PhD because there is no guideline. Why? It's because research is free. You should quality advice and you should agree that you are embark upon a journey, to find something new. So publication is a byproduct of that journey, but not the end product. Publication is a byproduct. You do a good research and you are ended up in publication actually. But it's not the publication that you are aiming at research. Research is to, you contribute the knowledge. Okay. So that aspect actually, so everyone must have to publish for it. See, there is no doubt. There are no, I think there's like everyone knows Q1 publication in the world. It's just like hard currency. Nowadays we are lacking of dollars. So academia is lacking of Q1 publication. This is hard currency. This is what other people can understand. This is where you trade. All the trades are done using Q1 publications. So Q1 publications are very important. So probably other people can also tell something if they want.
Yes, thank you so much. Yes, sir. Madam.
Yeah, I just want to secure publication. The difficulty, I think, it is where we should start. For example, if you in the end you wish, at the beginning of your research you wish to have results in Q1, then this is where you should start. You should start from reading Q1 journals. As the literature survey, you should read from literature with good quality. From there, you not only learn the technical background, you also know even writing, okay, even the language they are using. For example, in my area, there are certain journals, they are actually beyond the Q1, they are actually top. So if you read from those top journals, certainly the language is standard. The notation, the figure, the template in general is very standard. So that will help you. Eventually, you will by reading those things. And later, when you do your work, you benchmark with them. And eventually, if you keep maintain this quality, then you might just end up having your result with similar level. And that will help you at least to have quality publication. That means at the very beginning, you set a target. This is where I want to go. If you just want something quick and in a very short time, then you may not get to that point. Then you have other ways, which is shortcut. However, if your target is actually Q1 publications, this is where you should start from reading, from gathering the background, and from benchmark yourself. You should be there. This is what I understand.
Thank you, madam. These students, do you have any more points to clarification by our expert panelist? Okay, we will upload answers to your questions to Moodle. Link and other details will be sent. So we are going to wind up the research launch. So I would like to express our heartfelt thanks to our distinguished panelists for their valuable contribution to this event success. So thank you so much all. Dear researchers and students, we will meet again at the next research launch. Goodbye.